Hello everyone. In this video, we are going to see how we can implement univariate linear regression using normal equations, or how we can get the optimal value of theta using normal equations. In the last video, we did the same using gradient descent, and the conclusion in the last video was that we were not sure if the value of theta that we had received was the optimal value of theta or not. So in this video, we're going to get that exact optimal value of theta using normal equations. Again, I have the same library and the same data distribution that I had previously. You can just implement the same. For the process, we need to again create a design matrix, which I have explained very well in the previous video. If you haven't seen that, I'll keep the link above. Just go to that video, complete it, and then come back so that you'll understand this. Now, what is the normal equation? Well, if we see the formula for the normal equation, it says that the optimal value of theta is equals to X matrix, which is our design matrix, X transpose X inverse X transpose Y. So if we can just implement this formula, we'll get our optimal value of theta using only X and Y and without any kind of learning rate or anything else. If you're interested in the derivation of this formula, I'll keep a link of Stanford notes below, so that you can go through and understand how this formula is derived. Okay, let's go back and implement this formula in Python. So how do we do this? We define a function normal equation, and then we just implement it in the single line, which is np.linearalgebra.inverse. So we're doing X transpose X inverse into X transpose Y, and then we simply call our function and get our optimal value of theta. Well, if you remember our last video, the value of theta that we got was 2.97 and 9.59. I told you back then that we were not sure if that value of theta was optimal or not. You see, we just got that the previous value that we've received was not optimal at all, and the actual optimal value of theta for this set of data distribution is 4.27 and 9.40. We'll again go and see the visualization, and you might not see much change in here, but I'll keep the previous result visualization side by side as well, so that you can actually compare and see the main difference here. Okay, so this is how you implement univariate linear regression using normal equations. You can also do the same for multivariate linear regression when you have many number of features predicting one particular target variable, and we are going to implement multivariate linear regression in the upcoming video. So if you have any problem or any questions, just comment down below and I'll try to help you out. See you in the next video. Bye bye.